Alright guys, so I decided to make a little video about balancing chemical equations since this seems like something that everyone would benefit from. And I've got a selection of equations that I'm going to balance here, going from easy to medium to what I would consider hard, as pretty much the most difficult type that we're going to run into. So let's just get into it with the top one here. The first thing I'm going to do is I'm going to look for, usually I'm just going to start on the left-hand side and I'm going to say, okay, I've got a sodium atom here. So how many sodium atoms do I have, and where do I see sodium atoms elsewhere in the chemical equation? So right away I notice I see a sodium atom here and I see a sodium atom here. So I'm going to say, well, is it balanced? Yes, I've got 2 sodium atoms here, 2 sodium atoms here. So that seems like a good start. The next atom is sulfur. So sulfur, I've got 1 sulfur atom here and 1 sulfur atom on the other side. And remember, all the number of atoms that we see over here have to show up somewhere over on the right-hand side as well. So sulfur 1 here, that seems good. Moving right along to oxygen. Now oxygen, I've got 4 here, but I only have 2 on this side. So right away what that tells me is that I'm going to need 2 of these CO2 molecules. That's going to give me 4 overall oxygen atoms on this side to go with the 4 overall oxygen atoms on this side. Now I can balance the carbon. So on this side I've got 1 carbon so far, but I know that I'm going to need 2 because we put a 2 here. So I'm going to add a 2 in front of carbon. So this will give me 2 carbon atoms to 2 carbon atoms. And now that I've sort of gone through all the atoms, a good thing to do is just double check to make sure we are, all balanced. 2 sodium atoms, 2 sodium atoms, 1 sulfur, 1 sulfur, 4 oxygen atoms, 4 oxygen atoms here, 2 carbon atoms, 2 carbon atoms. So that one's good. Check. For the next one, this is going to get a little bit more complicated, but not too bad, just a little bit more involved. So again, I'm going to start with carbon. So usually I just start at the left-hand side and, try to balance things as I go. So carbon here and carbon here. And one thing that's nice about starting this way, and things that I would definitely look for, is that this atom only shows up once on each side of the reaction. If it only shows up once on each side of the reaction, it's pretty easy to go ahead and balance that. What I mean there is this oxygen, I've got oxygen here, but I've also got oxygen here and here, right? So it shows up twice on the right-hand side. So that's not a good atom to start with. It's going to be much easier to start with the other atoms that only show up once, and then do oxygen at the end. So 6 carbons here. That means I'm going to need a 6 in front of CO2, right? So 6 carbons here, 6 carbons here. Good. I don't see any other carbons anywhere else. So I can move on to hydrogen. 4 hydrogens here, only 2 hydrogens here. So I'm going to need 2 of those water molecules because that's going to be 4 hydrogens total, 4 hydrogens here. Cl2, I've got 2 chlorines on this side, and the only other place I see chlorines over here, and there's already 2 chlorines here. So the chlorines are already balanced. That's good to go. So now I can work on this oxygen. So the oxygen, I'm going to add up the total amount of oxygens on this side. So I've got 6 times 2 is 12 oxygens plus 2 oxygens equals 14 oxygens. So I'm going to need 14 oxygen atoms to balance out, right? So I've got 14 on this side, I need to have 14 on this side. So I can see that I'm just going to need a 7 in front of my O2. 7 times 2 is 14. So now this should be balanced. We can just do a quick check. 6 carbons, 4 hydrogens, 4 hydrogens, 2 chlorines, 2 chlorines, 14 oxygens, and then in total, 14 oxygens on this side, 12 here, 2 here equals 14. All right, the last one, and this is really the most difficult type that we're going to run into. Obviously, we can make these more and more complicated, but I think this is a good example of the level of difficulty that you should expect on the practice quiz and also on the exam. So for this one, again, I'm going to start at the left-hand side. I see 1 carbon here. I see 2 carbons here. I see only 1 carbon here. So I'm going to put a 2 in here. All right, so right away, just balancing the carbons out. Next, I've got hydrogen. Now in this case, I'm going to say, well, hydrogen shows up once on this side, but twice on this side. So I'm not necessarily going to try to balance it out right now. As it turns out in this case, 3 hydrogens and 3 hydrogens on this side. So it's already balanced. But let's imagine it wasn't. That would be something that I would put off until I've balanced everything else and then go back to hydrogen in that case. chlorine, one chlorine here, one chlorine here. So again, the chlorines are already balanced, so we don't really have to do anything with that. So now we've moved all the way to the oxygens already. So again, just like up here, right, I see that I've got two sources of oxygen on the right-hand side and only one source of oxygen on the left-hand side. So I need to balance these out, and I'm going to calculate again the total number of oxygen atoms on this side. So that's 4 oxygens here, 2 times 2, and then only 1 from this H2O, 1 oxygen. And that equals 5 oxygens total. So on the right-hand side, I've got 5 oxygens that show up. And now on the left-hand side, I've got O2. And as you might imagine, it's hard to make O2 equal to 5 oxygen atoms. If I have 1, I've got 2. If I've got 2 oxygens, 2 O2s here, that would be 4. And then if I go to 3 O2s, that would be 6. So I sort of skip over this 5 oxygens. So one strategy is just to put in 2.5, right? So if I had 2.5 of these oxygen molecules, well, then it would work out, right? Then I would get to my 5 oxygens that I need on this side. Unfortunately, it doesn't really make sense for us to say that we've got 2.5 oxygen molecules because we can't really just break that oxygen molecule in half. So once we get to this point, that's a good spot to be, but now, in order to sort of fix this up, we can multiply everything by 2. If we multiply every coefficient by 2, well, then we'll sort of make it so that each one of these adds up to a whole number, and everything will still be balanced because I'm just doubling everything, right? So my balanced chemical equation where I've just doubled the coefficient at every spot. And now let's just double check to make sure we've got it correct. So now I've got 4 carbon atoms on this side, 4 carbon atoms on this side. I've got 6 hydrogen atoms on this side, so 2 times 3 is 6. And I've got 4 here and 2 more here, so in total 6 hydrogen atoms. So again, 2 times 3 is 6 hydrogens. And then I've got 4 here and then 2 more here, which equals 6. I've got 2 chlorine atoms, so 2 times 1 is 2 chlorine atoms, and on this side, again, 2 times 1 is 2 chlorine atoms on this side. I've got 10 oxygen atoms in total, and I've got 8 oxygen atoms here, 2 more oxygen atoms here, so everything is balanced out. So again, this bottom one, I do expect you guys to be able to do this, and this is probably a good method of using, putting in the 2.5 here to equal the 5 oxygen atoms. There are obviously different ways, different methods that you can do this. This is just an example of one that I like to use and works pretty well for me.